Let's talk about innovation. Innovation is one of the ways that firms can escape from the Bertrand trap, where just having a little bit of competition, two firms, leads you to have zero profits in equilibrium. And that's because if your price is a perfect substitute and you price higher than your rival, people are going to buy from your rival. So it forces you to price as low as you can go and still make a profit, and in fact, until you make zero profit. So this is actually an area I know a bit about. It's my area of it's what I do my own research on. I teach a course on this. So for example, this is from my blog. If you're interested, I'll put up a link at some point, but this is like the reading list of what we do in my class. We're not going to cover the same kind of stuff that I teach in my class. Instead, we're going to talk a lot more about industrial organization and how the market structure and the extent of competition affects the kinds of innovations that are done, and also how innovation affects market structure and competition. So, to begin with, I thought we would talk about, we'd just go over some basic facts to get the lay of the land on innovation. Okay? So what I've got here is U.S. R&D spending as a percent of GDP. Okay? And this goes from 1953 all the way up to 2015. And we've got three main groups that do the spending. We've got business, we've got the federal government, and then we can add those two together to get a total figure. So if you look at the total, we've been roughly between kind of in the range of 2.5% of GDP for a long time, since at least the 80s or so. But who does that R&D has actually changed a lot over time. There's been this steady increase in business R&D, and there was this huge surge followed by a long-run decline of R&D funding by the federal government. So what explains this hump? Well, this area right here is the space race. When we spent a ton of money trying to go to the moon, and we ended up spending 1.5% of GDP on this kind of thing. And so, but prior to, you can see that the federal government was small in 1953, and so was business. Prior to these eras, R&D was not like a big expense, but now it's kind of this big ongoing recurring expense in our country. $2.50 out of every 100 go to inventing new products and processes and ideas. So how do we compare to other countries? What we've got here is on the horizontal axis, we've got spending on GDP as a percent of GDP. We've got expenditure on R&D as a percent of GDP, which is for the U.S. what we just looked at. But on the vertical axis, we've now got just raw dollars spent on R&D. So we'll see that the United States is not just a big country, but also a country that does a lot of R&D. There we are right there at the top. We account alone for 26% of global R&D spending. We're a big country, but we're not like slouches. Like if you draw a line down from here, we are at least in the top 25% of expenditure on R&D as like a share of our income. And since we're so big, that makes us like outsized important players. If you want to know who the next most important person is, that's going to be China, which spends a little bit less, both in terms of absolute value and as a share of GDP, but they're also an enormous economy, and so they account for another 22% of GDP. The European Union is a bunch of smaller countries, but collectively they account for 20%. They're in this circle, probably, but some of them might be a little outside it, and this probably has some countries that are not EU countries. Other major players, Japan, they spend even more of their GDP on R&D than the United States, but they're a smaller country, and so it actually adds up to about 10% of global R&D. And if you want to know who these two guys are, way out in the margin, spending more than 4% of their annual GDP on R&D, that's South Korea and Israel. Okay, again, smaller countries, but really heavily focused on R&D. But the fact that the U.S. is all the way up here, we spend a lot of money on R&D. We're the biggest leader in the world. This is like the United States is, in some sense, like the R&D laboratory of the world. It's one of the things that our country is exceptionally good at. The private sector is extremely innovative. Silicon Valley generates global companies that everyone around the world knows at a much higher rate than probably any other country in the world. And our universities that do basic scientific research are also the best in the world. There are, of course, other universities outside of the United States that also have exceptional science and engineering departments and things like that. But the U.S. consistently has, like, by far the most, if you look at sort of like the top 25 or the top 50 universities. And we've had that position for a really long time. So we're going to escape this. And let's talk a little bit more about kinds of R&D. So there's a few main divergences or kind of types. There's applied R&D, and that is R&D, so research and design that's close to commercial application. So this would be the R&D that Apple does to invent the iPad, or Google does to improve the search algorithm. It's R&D that in the short term you kind of know what you're doing it for and why you're doing it, and you're going to you know the way to make money off of it. Okay? You can go back one step, and there's another kind of R&D that we call basic R&D. And this is characterized by being far from commercial application, and it's really about fundamental knowledge. It's about understanding how things work. So this tends to be the domain of, for example, universities. Trying to figure out how universities trying to figure out, for example, how cells work. It's not always the case, but it tends to be the case that applied R&D is something that the private sector does, and basic R&D is something that the government does. And the reason is really that basic R&D is a public good. And if you remember from your Econ 101 and 301, public goods are called they're goods that are non-excludable and non-rival. And what does that mean? Non-excludable means that I can't prevent other people from using and accessing the idea. Knowledge has this characteristic where it is very difficult to discover something and use that knowledge and not disclose that knowledge to other people. So, for example, if I have an idea for a certain kind of new way of building an engine, and I sell the engine, people can take it apart and see what I did, and then now they have the idea. They didn't do the work, they didn't do the R&D, but they have been given the idea by me. I didn't want to give it to them, but there's no way I can exclude them from possessing it if I want to apply the idea. Non-rivalry means that multiple people can use the thing at the same time. So the classic simple answer is, if I have an apple and you have an apple, and then we trade apples, we each end up with one apple. If I have an idea and you have an idea and we trade ideas, now we each have two ideas. And that's because ideas are non-rival. Another way to think about it is it's like candle flames. If you light your candle if you have a candle that's not lit and I have one that's lit, and I lend you the light to light it, now we both have light. Your light didn't get transferred from my candle to yours. And this makes it, public goods are hard to invest in. There's going to be insufficient private investment. And that's because a lot of the benefits of public goods will flow to people who did not make the investment. You can't stop them from using it, and we want lots of people to use it, because once it's discovered, it's like free to extend that idea to multiple people. And so that means that the incentives for like the government to do it the incentives for like a private company to do it are not very good. All right. So we tend to have the private sector focus on the applied R&D, where it's close to commercial application, and usually it also has the nature of a public good, but it's not as much of a public good as basic R&D is. We'll talk a little bit later, towards the end of these videos, about how firms deal with the fact that R&D investments are partially non-excludable and non-rival. But first, let's just figure out some let's put those issues aside and think about some basic issues of how much R&D you should do given different types of market structure.